So Laplace transform is a way to turn some functions into other functions that can simplify the calculations. It is used to convert the hard work of integration to just by doing simple ordinary algebra. So we are here to derive the Laplace transform of the function sin bt. The Laplace transform of sin bt is equals to the integral of e to the negative st sin bt. The first thing we need to do is apply the integration by parts. We let dv is equals to e to the minus st. We integrate dv so we can get the v, which is equals to negative 1 over s e to the power of negative st. We let u, which is equals to sine bt here, then get the derivative of of u, so du is equals to b cosine bt. We substitute u and v here minus integral of v du, and we get this equation. Y is equals to negative 1 over s e to the negative st sine bt minus the integral of negative 1 over s e to the negative st b cosine bt. Then we factor out b and negative 1 over s, and which will result this equation: negative 1 over s e to the negative st sine bt plus b over s integration of e to the negative st cosine bt. We need to apply again the integration by parts. We let u cosine bt get the derivative so we can get du, which is equals to negative b sine bt. We let dv is equals to e to the negative st. Integrate it so we can get v, which is equals to negative 1 over s e to the negative st. So y is equals to negative 1 e to the negative st sine bt plus b over s times the result of the integration by parts here. Then we factor out this negative b over s and distributed this form b over s to get this equation: negative 1 over s e to the negative st sine bt minus b over s squared e to the negative st cosine bt minus b squared over s squared integral of negative st sine bt. This part here, the integral of e to the negative st sine bt, is equals to the y here. Here y is equals to the integral of 0 e to the negative st sine bt dt. We then substitute this y. Here we substitute this y. So the result equation here is here: negative 1 over s e to the negative st sine bt minus b over s squared e to the negative st cosine bt minus b squared over s squared. We transpose this term and the equation will turn to this: y plus b squared over s squared y equals negative 1 over s e to the negative st sine bt minus b over s squared e to the negative st. We factor out y here and e to the negative st, which will turn to this: 1 plus b squared over s squared times y is equals to negative e to the negative st 1 over s sine bt plus b over s squared cosine bt. Now the equation will turn to this from this, and we evaluate this to 0 to infinity. We can evaluate this because we integrated this part from 0 to infinity and this part 0 to infinity. Then we get the limit of this term from to infinity, which is 0, minus this, substitute this 0 to this, so e to the power of 0 is 1 times the sine of 0, which is 0, plus cosine of 0, which is 1, so the b over s squared will remain. Then we multiply s squared over s squared plus b squared to the whole equation, then we get the Laplace transform, which is y is equals to b over s squared plus b squared.